Hello, I'm ETarte, math teacher. I have a math challenge for you with prizes available. When I was a middle school teacher, I taught divisibility tests so that given a large integer, you can tell by a simple test whether it's divisible by 2 or by 3, by 5, by 9, by 10, by 11. For example, it's divisible by 2 if and only if the ones digit is 2, 4, 6, 8, or 0. Well, in my opinion, one of the more interesting divisibility tests is the 11 divisibility test. An integer is divisible by 11 if and only if, when you add up both sets of alternating digits, you get either the same answer or the answers differ by a multiple of 11. I'll give you some examples. Consider this four-digit number 3,861. The alternating digits 3 and 6 add up to 9, and the other digits 8 and 1 also add up to 9. Both add up to the same thing. That means that 3,861 is a multiple of 11. And indeed, 3,861 divided by 11 is exactly 351 with no remainder. Now consider the three-digit number 649. 6 plus 9 is 15, and that middle 4 stands alone. It's only 4. Well, 15 doesn't equal 4, but 15 minus 4 is 11. That means that 649 is divisible exactly by 11. And indeed, 649 divided by 11 is exactly 59 with no remainder. Now consider the six-digit number 398,794. The alternating digits 3, 8, and 9 add up to 20. The other group of alternating digits, 9, 7, and 4, also add up to 20. They both add up to the same number, and that means that this six-digit number is exactly divisible by 11. And indeed, that number divided by 11 equals exactly 36,254 with no remainder. So I taught this to middle school students for 17 years. An intellectually curious student would ask me, "Why is that?" No student ever asked me that. It would be difficult for me to explain to a middle school student why this is so. I would need to use algebra. I have never until today explored why this divisibility test works. But I explored it today and figured it out, and this is my challenge to you. Suppose that you have any six-digit integer. Show by some algebra that if both pairs of alternating digits add up to the same number or differ by a multiple of 11, then this six-digit number is a multiple of 11. When I make my solution video, I will use capital letters as variables, the letters A through F in order from right to left, A being the numeral in the ones place, B in the tens place, C in the hundreds place, and so on. And if we do a good job of this, we will see that our reasoning applies not only to integers containing 6 digits, but integers containing any number of digits. And we will also be able to see that our steps are reversible, and that will establish the converse, namely that if the integer is a multiple of 11, then those two sums are either equal or differ by a multiple of 11. If you can meet the challenge, please don't give me your result here in the comments section of this video. Instead, go to my profile page, find Send Message, and message me your answer. If your solution makes sense to me, you can have a prize if you want it. The prize that I offer is an audio file of me playing a selection on my piano, a selection that I recorded many years ago and now have in my archives. If you need help deciding whether you would like a prize, I invite you to go to my profile page, find one of my piano videos playlists, and watch one or more of those videos. If you want the prize, please request it and include your email address. In any event, I hope that if you work on this challenge, it will give you mental stimulation and pleasure. To all of you, thank you for watching this video.